Welcome to this deep dive into one of the most fundamental yet um, often misunderstood topics in physics, the electromagnetic spectrum.
Which is from Unit 8 electromagnetic waves. Right?
Exactly. Our mission today is to simplify this concept so thoroughly, in fact, that you stop seeing it as just abstract theory and start seeing it for what it is. The engine driving everything from our mobile phones to, the light from the sun.
So this is for students who find physics a bit challenging.
Absolutely. This discussion is designed to give you the foundation you need to secure maximum marks. So let us start with a simple everyday curiosity. We are using radio waves, well, all the time, for communication. They pass through concrete walls so effortlessly.
Yeah.
And yet we use light waves, a form of visible light, just to see, and they are blocked by those very same walls. These two things, radio and light, they seem fundamentally different.
They absolutely do. One is for communication, the other is for vision. But the surprising thing is, I've read that they are both made of the exact same physical thing, a propagating electromagnetic disturbance. How is that even possible?
That is precisely the right question to ask, and it is the key to unlocking so much of modern physics, this confusing reality that radio, light, microwaves, X-rays, they're all fundamentally the same thing. That was the masterstroke of James Clerk Maxwell.
Before him, they were treated as separate forces.
Connected, yes, but ultimately separate. Maxwell realized they are not just connected, they were two sides of a single unified coin, the electromagnetic force. This deep dive will explain the revolutionary mechanism behind that unity. So let's establish the core idea, the zero-level concept. Electric fields, which we call E, and magnetic fields, B, are intimately tied together.
Right, like from Faraday's law.
Exactly. We already know from Faraday's law that if you change a magnetic field, you must create or induce an electric field. That's basically how generators work. Maxwell completed the symmetry. He proved that a changing electric field must also create a magnetic field. It is a perfect reciprocal relationship.
Okay, so they create each other.
Yes. And when these two fields continuously generate and regenerate each other, they create this self-sustaining disturbance, an energy packet, which then travels through space, needing nothing else.
I get the reciprocity, the idea that E creates B and B creates E, but I still have it out. Where does the energy come from? And if nothing is physically moving, if there is no rope or water, how does this disturbance travel?
That is where the power of the concept lies. Let us use an analogy. Let's call it the crowded room dance analogy to visualize this.
Okay.
Imagine a very crowded room where people are dancing. A push forward, let's call that the electric field, from one person causes the next person to sway sideways. That's the magnetic field.
A push forward causes a sway sideways. Got it.
But because of how crowded it is, that sideways sway, in turn, creates a new push forward on the person right after them. It becomes this endless, continuous feedback loop.
So the push creates the sway, and the sway creates a new push.
Precisely. And that carries the disturbance across the entire room. The wave is not the people. The wave is that coordinated movement of the fields themselves. To make a solid mental image, let's try another one, the vibrating buoy analogy. Picture a vast, dark ocean. This represents empty space, a vacuum.
Okay, an empty ocean.
At one point, a charged particle or buoy starts oscillating. It's moving rapidly up and down. This oscillation immediately creates two disturbances that are perfectly locked together and perpendicular.
Perpendicular, how?
You have the vertical wave on the surface, that is the electric field oscillation, and at the exact same time, you have a sort of swirling motion, a current happening horizontally. That's the magnetic field oscillation.
So one up and down, one side to side.
Exactly. Both are perpendicular to each other, and crucially, both are also perpendicular to the direction the energy is actually traveling. These oscillating fields are the electromagnetic wave. This is why they are the universe's most efficient, unstoppable travelers.
Because they don't need a medium.
They don't need any medium to push against. Unlike sound or water waves, they just move through the vacuum at a fixed speed. The speed of light, c. Now, let us transition to the formal theory. If this reciprocal relationship is so crucial, we have to understand the conceptual loophole that Maxwell had to close. We need to see how Ensert formally defines the missing piece of the puzzle, the displacement current.
Okay.
So the core issue came up when applying Ampere's law to a charging capacitor. Current flows fine in the wire. We call that the conduction current, IC. And Ampere's original law correctly predicts a magnetic field around that wire.
Right, that's straightforward.
However, between the capacitor plates, there's an insulator. A vacuum maybe, or air. So no real current flows. IAC is zero there.
So the law should say there's no magnetic field.
The original Ampere's law would predict exactly that, no magnetic field, but experimentally, a magnetic field is observed there. This inconsistency was physically and mathematically intolerable.
So the formula was just wrong in that one tiny area, in the gap of the capacitor. But wasn't Ampere's law working perfectly fine for steady currents? Why change a fundamental law just for this one temporary state?
Because physics demands symmetry. It demands consistency. Maxwell realized that between the plates, while charge is not physically moving, the electric field is changing very rapidly as the capacitor charges up.
Ah, all right.
He proposed that this change in the electric field, it acts exactly like a physical current, but only for the purpose of generating a magnetic field.
It's not a real current, but it creates a magnetic field as if it were.
Precisely.
Yeah.
He called this conceptual correction the displacement current, IVD. It is not moving charges, but the energy associated with that changing electric field. When Maxwell added this term, suddenly the equations became consistent, complete, and perfectly symmetrical. This modification gave us the generalized Ampere-Maxwell law. Now, could you tell us what the law means? What do we include now according to the new law?
Okay, so we now have to include both the actual current, IC, and this new term, the displacement current, ID, which is proportional to the rate of change of electric flux.
Exactly. And that simple mathematical move established perfect symmetry. Faraday's law tells us a changing B creates an E, and the Ampere-Maxwell law tells us a changing E creates a B. This perfect, balanced mechanism is what makes electromagnetic waves possible.
And this is all happening in a vacuum.
Yes, and the crucial constants governing this are mu naught, the permeability of free space, and epsilon naught, the permittivity of free space. You can think of these as constants that describe the stiffness and responsiveness of the empty canvas of space itself. And here is the amazing part. If we plug these constants into Maxwell's equations, they predict the speed of the wave. C equals 1 over the square root of b times 1.
And that number is all.
When you calculate that number, it comes out to 3 times 10 to the power of 8 meters per second. The speed of light. It was a stunning realization. Maxwell derived the speed of light from purely electrical and magnetic principles, proving light is an electromagnetic wave. Hope everything is clear so far. This deep dive is from ProfSam.com. That is ProfSam.com. Now, let us take a minimal worked example just to understand the scale we are dealing with. We mentioned a typical FM radio station broadcasting at, say, 100 megahertz. That's 10 to the power of 8 hertz.
Okay.
We use the fundamental wave equation. C equals fru. Speed equals frequency times wavelength. Here, C is constant.
We want to find the wavelength.
Yes.
Yeah.
So AA equals it.
Yeah.
If we take C as 3 times 10 to the 8 meters and divide it by the frequency, 10 to the 8 hertz, the wavelength we get is precisely 3 meters.
3 meters. That is taller than a door frame. So an invisible massive wave 3 meters long is carrying the music signal into my radio.
Precisely. Now compare that 3-meter wavelength to visible light, where the wavelength is measured in, well, in nanometer, billions of a meter. It really highlights that the only difference between a giant radio wave and the light you see is the frequency of that self-sustaining oscillation.
It's incredible.
Speaking of constants, the speed c over 1 over root mu mirror is only true in a vacuum. This links directly to our next unit on optics. When an EM wave travels through a material, like glass, the constants change to the medium's permeability and permittivity.
So the speed changes.
The speed becomes v over 1 over root me. This change is why light slows down in matter, a concept which is crucial for understanding refraction. Now, let us talk about the silent killers. The 3 misconceptions that frequently cost students valuable marks in exams, even after they think they understand the core concept.
Okay, this is important.
Misconception number 1. Many students generalize from sound and water waves and wrongly assume that EM waves require a medium, like air or, the old idea of ether, to travel.
Which is wrong.
Completely wrong. The correct idea is what we just discussed. EM waves are oscillations of the fields themselves. They propagate through a vacuum and travel fastest there. Remember, EM waves are the disturbance, not disturbances of something else.
So the light from the sun doesn't need any air to travel across space. It's the electric and magnetic fields doing a self-sustaining dance across the complete void. That's why it gets to us. That makes sense now.
Misconception number 2. This one is about the field direction. The wrong idea is that the electric field and magnetic field are parallel, that they just oscillate back and forth together.
But you said they are perpendicular.
The correct idea is that E, B, and the direction of propagation are mutually perpendicular. They form a perfect 3D coordinate system.
It's a bit confusing to visualize immediately. So if the wave is propagating towards me,
Yes.
the electric field might be oscillating up and down,
Yeah.
and the magnetic field must be oscillating side to side. It's always that 90-degree separation.
Exactly. That 90-degree relationship between E and B and their perpendicularity to the direction of motion is the defining characteristic of this transverse wave. Finally, misconception number 3, thinking that visible light, X-rays, and radio waves are fundamentally different physical phenomena.
But their uses are so different. That's why it's confusing.
The wrong thinking arises because of their totally different names and uses. The correct idea is that they are all the exact same wave electromagnetic waves. They differ only in frequency and wavelength, and thus in the energy they carry. The visible range is just a tiny, tiny sliver that our human eyes happen to be able to detect. Let us organize the knowledge of the entire electromagnetic spectrum using a simple memory anchor, a mnemonic. We arrange the regions from the lowest frequency, longest wavelength to the highest frequency, shortest wavelength. Our mnemonic is Ramicrobes extra germ.
Ramicrobes extra germ. What does that stand for?
It stands for radio waves, microwave, infrared, visible. You fill in the V in the middle, ultraviolet, X-rays, and gamma rays.
Ah, okay. That's clever.
And to help you encode the relationship, try this phrase and gesture. From radio to gamma, long waves are weak, short waves are strong.
How does the gesture work?
You imagine your hands far apart. That's the long wavelength of radio. As you move across the spectrum, you slowly bring your hands closer together while oscillating them faster and faster until you are rapidly wiggling your fingers for the high-frequency gamma rays. This physical gesture encodes that inverse relationship. Now, let's just quickly go through the applications, which depend entirely on the wave's frequency and energy.
Okay.
The lower frequency waves, like radio waves, have very long wavelength meters to kilometers. This makes them excellent for carrying information over long distances without being blocked easily. Next, microwaves. They operate in the gigahertz range. Their shorter wavelengths are crucial for things like aircraft radar and satellite communication.
And for cooking. The domestic use is the most fascinating part. I understand microwaves cook food by making water molecules vibrate, and that creates heat.
That is absolutely correct. The frequency of a microwave oven is specifically tuned to match the natural resonant frequency of water molecules. It's a very efficient energy transfer. Next up are infrared waves, which we simply perceive as heat. These are produced by hot bodies and molecules. They are essential for thermal imaging and even simple things like household remote switches.
And then visible light.
Then we hit that incredibly narrow band of visible light. It's a tiny range, about 400 to 700 nanometers. Our visual system evolved to detect only this sliver because it is the most abundant energy range reaching Earth's surface. Moving higher in energy, we encounter ultraviolet or UV rays. These are energetic enough to break chemical bonds.
Which is why they cause sunburn.
Exactly. Sunburn and damage. But we also use them beneficially for tanning and for killing germs in water purifiers.
It is incredible. Microwaves just gently excite water molecules for cooking, but UV rays are energetic enough to actually damage or kill living cells and bacteria. It's the same wave, just a slight increase in frequency causing a massive change in interaction.
Precisely. And that brings us to X-rays. They are produced by stopping high-energy electrons suddenly against a metal target. Their extremely high energy means they can penetrate matter easily. They pass through soft tissue, but are absorbed by dense materials like bone.
Making them indispensable for medical imaging.
Of course. And finally, at the very highest end, we have gamma rays. These have the shortest wavelengths, less than a picometer, and the highest frequencies. They originate from nuclear reactions and radioactive decay, carrying immense energy.
Which makes them dangerous.
Incredibly dangerous if uncontrolled, but they are harnessed medically to destroy targeted cancer cells in radiotherapy. It is genuinely astonishing that the same self-propagating mechanism is responsible for 3-meter radio waves and these ultra-short cell-destroying gamma rays.
That truly contextualizes the power of frequency. If you grasp this one concept, you unlock almost all of modern communication and medical technology.
That is the profound realization that this unit provides. So to conclude our deep dive, let us provide exactly 3 concise, exam-safe factual summary points for your revision.
Okay, the 3 main points.
Point 1. The electromagnetic spectrum classifies all radiation, from long radio waves to short gamma rays, entirely based on frequency and wavelength.
Okay.
Point 2. All electromagnetic waves travel at the constant speed of light, c, which is 3 times 10 to the power of 8 meters per second in a vacuum. And the speed is independent of their frequency or wavelength.
Got it.
And point 3. Different regions of the spectrum are produced by different physical mechanisms, like oscillating charges for radio waves versus nuclear reactions for gamma rays, and they interact with matter distinctly depending on the energy or frequency they carry. Now, here's a final thought for you to ponder. Since the speed of light is constant in a vacuum for all EM waves, what happens when light travels through glass or water? Why do different frequencies, which we see as different colors, sometimes travel at slightly different speeds in a medium, leading to that beautiful phenomenon we call dispersion? Think about how the medium's constants might differ slightly for different oscillation rates. To get maximum marks in 12th CBSE, physics, chemistry, and maths, visit ProfSam.com.
That is P-R-O-F Sam.
Yes. ProfSam.com. Thank you for joining us for this deep dive. All the best for your preparations.